All right, so have you ever stopped to think about how one single giant computer in some far-off data center can run hundreds of different websites all at once? It really is a kind of magic that makes our entire digital world go round. So today, let's pull back that curtain. We're going to dive into the great abstraction race and see how we learn to make our computers do way more with way less. It all boils down to this one central question, right? How do you take one monster of a physical computer and slice it up into dozens of smaller, independent ones, and do it safely and efficiently? Well, the answer to that question gave us two game-changing technologies, virtualization and later containerization. But, to really get why these ideas are such a big deal, we got to take a little trip back in time, back to the old way of doing things. It was a simple setup for sure, but man, was it inefficient. So take a look at this. In the old days, everything was welded together. The application, the operating system, and the physical hardware, the actual metal, were one single unit. This meant you could have this incredibly powerful server, but if it was only running one simple application, it might be using, I don't know, maybe 10% of its power. The other 90%? Just sitting there, burning electricity. A total waste.
Yeah, that kind of wastefulness just wasn't going to fly for long. The industry desperately needed a way to break that rigid chain between the software and the hardware. And the first truly revolutionary solution to this was virtualization.
So what is virtualization really? Well, at its core, it's an illusion. It's a super clever magic trick. You install this layer of software that takes one real physical server and makes it look and act like it's actually 10 or 20 or 50 separate little servers. And this idea, which, believe it or not, actually goes back to the 1960s, is what made the modern cloud possible, period.
Okay, that's the theory. To make this really concrete, let's imagine a scenario. Let's meet Alice. She's got a small hosting business, she's got one big, beefy server, but she has a bunch of customers who all want different things. So what's she gonna do? Here's her setup. It's a pretty solid machine, right? 4 CPUs, 8 gigs of memory. That's a good amount of power to work with. But right now, it's all just one big pile of resources. All her eggs are in one basket. And here come the customers. You've got Bob, Charlie, and Daniel. And look, their needs are all over the map. One wants more memory, another wants more CPU. And here's the absolute kicker. They all need to be completely isolated. Bob's app can't crash just because Charlie's code has a bug. No way. They can't even know the others exist.
And voila, this is the solution. With virtualization, Alice can neatly carve up her one physical server into 3 completely separate, isolated virtual machines, or VMs. She gives each customer the exact slice of resources they asked for, and everybody gets their own private digital sandbox to play in. Problem solved.
Okay, so that was the what. Pretty cool, right? But now let's get into the how. What is this magical software layer that actually makes all of this possible?
Well, the secret ingredient has a name. It's called a hypervisor. And you can think of a hypervisor as the ultimate traffic cop for a server's resources. It sits between the actual hardware and all those virtual machines, and it's constantly directing traffic, deciding who gets what CPU time, who gets what slice of memory, and making absolutely sure they don't crash into each other. Now, this hypervisor gives VMs 3 incredible superpowers. The first is isolation, which we've already seen. One VM can completely crash and burn, and the others won't even notice. The second is encapsulation. This means you can save the entire state of a VM, the whole computer, as a single file. It's like a save game for a server. And the third is portability, and this is the one that'll really blow your mind. It means you can move a running computer from one physical box to another.
Now, just so you know, not all hypervisors are created equal. There are 2 main flavors. You've got Type 1, or bare metal. This is the pro stuff. It runs directly on the hardware for maximum performance. This is what powers the big cloud data centers. Then you have Type 2, which is an app you can run on your own Windows or Mac computer. It's way easier to use for testing stuff, but it has a little extra overhead. So back to that mind-bending portability superpower, how on earth do you move a running computer with 0 downtime? Well, it's this incredible high-speed dance. The hypervisor starts copying all the VM's memory to a new server. While that's happening, it keeps track of any little bits of memory that change, and it sends those updates over too. It does this over and over, faster and faster, until it's almost perfectly in sync. Then, for a fraction of a second, it freezes the original VM, sends the final tiny change, and tells the new server, you're it. The whole thing happens so fast, the software inside never has a clue, it just moved across the data center. So VMs were a total game changer, but they did have one drawback. They were kind of heavy. Every single VM needs its own entire copy of an operating system. That means they're big, we're talking gigabytes, and they can be slow to start up. So naturally, the world started wondering, is there an even lighter, even faster way to do this? And that led to the next big leap, containerization. A container takes a totally different approach. Instead of virtualizing an entire fake computer, a container is just a neat, tidy little package that holds one specific application and everything it needs to run, all its code, all its libraries, everything. Think of it less like a virtual house and more like a perfectly packed suitcase for your app. Now, if you remember just one thing from this whole explainer, please make it this quote right here. It's so important. VMs are an abstraction of the physical hardware. They trick an app into thinking it has its own metal. Containers are an abstraction of the operating system. They trick an app into thinking it has its own fresh OS. It's a subtle but massive difference. Okay, time for the main event. Let's put these two technologies side by side and really see how they stack up. The differences become crystal clear when you look at them this way. And this right here, this picture tells the whole story. Look at the VM stack on the left. See all that repetition? Each VM has its own bulky guest OS. That's a lot of baggage. Now look at the container side on the right. See how clean that is? All the containers are sitting on top of a single host OS, sharing its core engine or kernel. That is the secret to their efficiency. Let's just break this down by the numbers. VMs abstract hardware, containers abstract the OS. That leads to a crazy difference in size. We're going from gigabytes for a VM down to megabytes for a container. And the startup time? A VM can take a few minutes to boot up its whole OS. A container? It can start in seconds. It's a whole different league of speed. But hold on, it's not a total knockout for containers. Remember that shared OS kernel? Well, that's their superpower, but it's also their potential weakness. Because they're all sharing that one kernel, the isolation between them isn't quite as rock solid as it is with VMs. A major security flaw in the host OS could, in theory, put all the containers at risk. So let's zoom all the way out. We've got these two incredibly powerful but different ideas. How do they actually fit together to power the internet as we know it? This slide perfectly captures the entire journey. We started with that old, wasteful one server, one job model. Then virtualization blew the doors open, letting us slice those servers up into efficient VMs. And then containerization came along and gave us an even more lightweight, agile way to run things. But here's the coolest part. They're not enemies. Today, it's super common to run containers inside of a virtual machine. That way, you get the ironclad security and isolation of a VM with the speed and portability of containers running inside. It's the best of both worlds. And that brings us to our final thought for the day. If containers are so much lighter and faster, why haven't they just replaced virtual machines completely? Why are VMs still the absolute bedrock of modern cloud computing? It really makes you think, doesn't it, about that constant tug of war in technology between raw speed and absolute security.